Hello everyone. In this video we're going to talk about password hashing. So what is password hashing? It's a way to keep users' password relatively safe even if there's a data breach. Um, yeah, there's an S here, I don't know why. Alright, terms. So hashing function, the input in this case it's going to be the password. The hash is going to be the output of the hashing function. The salt is just some random value, random data, and the cost is the amount of times we do the hashing function. So the basic concept. We have a password, and we have a one-way function. That means given an input, it's always going to output the same thing, but from the output, we cannot guess the input. And why, in this case, we cannot guess the input? Because modulo 2 is means that for example, for an odd number it's gonna output 1, for even number it's gonna output 0, and what this means is that having an output of 1, all the numbers that are odd can possibly be the password. Obviously, there's hashing functions that are much more elaborate and unpredictable, like SHA-256. For verification, what we basically do is that we take the hash password and we take the password to be verified, and we simply apply the hash function onto the to be verified password, and we compare if the both hashes match. Alright, a step further, users will sometimes have the same hash. In other words, there's a high chance that their passwords are identical. And fortunately, we have something to fix this. We have the salt. The salt is just some random data that we will use in our hashing function. So here we input the salt as the second argument, and the output is going to have the salt first and the hash, and inside here the salt is going to multiply the input, and here we generate some random salt between 0 and 99. This is not good enough, because in nowadays we have those super fast computers. They can easily decrypt passwords in a couple of iterations, so we need something stronger. So we have the cost. The cost is the amount of effort needed to decrypt and hash a password. It will be referred. I will refer it as the amount of salt rounds from now on. So yeah. So this is the new implementation. We have a password, which is just a super large number. We have our hashing function. We take the input, the salt, and the salt rounds. And over here, we just set the output to the input. And we repeat for the amount of salt rounds. And we keep changing the output with itself. That means for the 0th iteration is going to be input plus salt and modulo something, and we save it as the output, and we repeat this the amount of salt rounds needed, and finally we return I forgot to return here. We return the amount of salt rounds, the salt, and the out. Why do we return the salt rounds? Is so that we can verify with the same data. Same goes for the salt, if I didn't mention. Yeah, and here we generate the salt, and here you can see that we do 10 iterations. Alright, well, in some implementations, the amount of iterations is in fact the salt rounds cost to the power of 2. That means iterations equals salt rounds power to the 2. Let's make an actual password hasher in Node.js because this one is only using numbers. It's not very useful. So let's create a new file. And in this file, I'm just gonna open my little reference here. Alright, so we're gonna import a crypto. So const crypto. Require. There you go. Afterwards, we're just gonna create our hashing function. So function hash, hash, I guess. I will call hasher. So let's define our data, the password data. We're also gonna define the fault and the cost. In this case, I'm just gonna put the cost, the amount of salt rounds first, and the salt at last. We're gonna set a default value to the cost, and yeah. And in this implementation, we're gonna do the power of 2 for security. So if the salt is not defined, we're gonna create a salt. So if there's no salt, we're gonna create a salt equals crypto dot random bytes. And how many bytes of randomness we want? We want 16. And we're gonna go make it into a string, and we're gonna use the base 64 encoding. Alright, this is good. Now we're actually gonna create our hasher. So the actual hash object. So let hash o equals crypto create hash, and we're gonna use the SHA-256 hashing function. So for let, and now we're gonna iterate it over the amount of cost to the power of 2. So for let I equals 0, I smaller than oh, I made a little mistake. Yeah, it's 2 to the power of cost. Yeah. What was I thinking? Oh, let's fix this. 2 to the power of cost. I will publish this repo and with the corrections. Alright, so 2 to the power of cost, I++, and we're basically just going to update the hash with the salt and the data. Finally, we're gonna return the entire thing to string. So return, and first we need to specify the cost of the thing. So we're just gonna do cost to string. This is good. Cost to string plus, I guess just cost will work. Cost plus dot. Dot will be the separator between all the values. Salt plus, we're gonna add a dot. Let's do something cleaner. So cost, salt, and the hash object, we're gonna digest it. And digest mean we just do the summation. And base 64. There you go, and we join with dots. Alright, so now we have our hashing function. Let's create our compare function. So function compare. And what compare will take? It will take the data and the hash that this thing generated, meaning a string separated with dots, with all the values we need to use. So now that we have this, we just extract the cost, the salt, and the hash. I mean, not the hash. Yeah, the hash. Yeah, this is a hash. I mean the sum. Yeah, the sum. All right. So so we just do, I guess, const. I should use const here for const. Alright, const, and we're gonna do array destructuring. So we have our cost, our salt, and our sum. And what we're gonna do is that we're gonna take the hash and we're gonna split with the dots. So now that we have all the data that we need to run the hashing function again. So let's create a thing. So const, I guess new hash. That means the new output that we use with the data equals hasher, and we're gonna put the actual data, the cost that we extracted, and the salt. Yeah, we don't even need we don't need the sum here. We can remove it. And afterwards, we're just gonna compare if the both hashes matches. So return new hash equals hash. So basically, what it means if it's false, it means that you have the wrong password. If this thing returns false, if it's true, that means you have the same password. So let's actually test this thing out. So I guess console.log. Let's create a password. Yeah. Const password equals hello world, and we're gonna hash this. Const hash equals hasher, and we're gonna hash what? We're gonna hash the password, and yeah, this is good. And now we're gonna compare. So first we're just gonna console.log compare password with itself. It should return true. So let's test this thing out. Oh, not password with itself, it's password with hash. Okay. Alright, so let's turn on the terminal, and yeah. As you can see, I'm using a WSL. So let's run this node.js, and it returns true, obviously, because it's the same password. And if we want to see what the hash looks like, console.log hash, and this is a hash. As you can see, we have the sum, we have the salt, which is 16 bytes, and we have 10, which is the amount of salt rounds. We're gonna make this look a bit better. Let me see if I'm running out of time. Yeah, let's make this look a bit better, because as you can see, we have this thing, which is kind of ugly in my opinion. Yeah, so what do we do is we can just remove them. So slice, and what do we slice? We slice from 0, and we remove the last two characters. So now it should remove the two equals from here, and it's gone. Alright, now we can remove the last equal from here. So it's going to be here. After digest, we're gonna slice, and we're gonna slice from 0 to -1, meaning remove the last one. And here we have a clean looking hash. Alright, so this is pretty much it. This is how you implement a password hasher that works relatively well in Node.js without any library. Thanks for watching, and I hope you enjoyed this video. Goodbye.